Seeking English S.A.T. Workbook, page 428, problem 4. This has become one of my favorite problems, although it did not start as one of my favorite problems. This is a good problem for learning how to develop good instincts about how to attack a problem. The individual steps of this problem are not difficult, and you can probably do them in various orders and get the same result in about the same amount of time. But to try to understand where you're going with this problem is crucial in order to make sense of what you're trying to eliminate and how to eliminate it. I haven't put the answers on the board, which are possible answers are 4, 8, 12, and 16. So they give you some clues. Often, if a problem is more difficult than most of the problems in this practice book and on the real test, they will give you certain hints that will help speed things up if you happen to notice what they are. In this case, you've got everything is this x base here, okay? And they just told you x is greater than 1, just in case, okay? What you're solving for is the m squared minus n, and as you see, as not shown in the book, I put it directly under the m squared plus n. This is your hint. Things that you need to make sure go away are you need to get rid of all denominators, which is my favorite part of almost any process. Get rid of the denominators, and you actually need to get rid of this x base. You need to get rid of the x base. How is that possible? Well, if it's not obvious to you, hopefully it will be by the time you take the test. In the meantime, this is what we're solving for. You don't want to get rid of your m. You don't want to get rid of your n, but this 4 has to become a 2, okay? And this n and this 2 has to become an implicit 1. How's that going to happen? Well, if you multiply these two things together, you get m squared plus n, okay, times m squared minus n. But teacher, the book doesn't say to do that. Well, it doesn't say not to do that. So I'm going to suggest try to use your imagination on a similar problem to try to figure out what would happen if you could work backwards a little bit. Here, if you did multiply these together, but teacher, I wouldn't know what it is. I know you wouldn't know precisely what it is, but you would know that it equals. And make sure I can fit this here. The middle terms are going to cancel here. What you're going to get is m to the 4 minus n squared. Okay, and there you have your m to the 4, and you have a negative n squared. Okay, but you have an n squared there. So this is where you're trying to get. If you can solve for this thing, then you can factor out the 3 and you can get the other part of it. So how are you going to get there? Well, as I said before, denominators, you don't want those. So I'm going to do this. I'm going to move this up here, okay? X to the 12, excuse me here. And I'm going to move this diagonally because you can do that. This is an imaginary 1 over here, or x to the 0 if you prefer. In any case, I'm going to move it up here, times x to the n minus 2. Sorry, x to the n squared. Okay? And then you don't need these at all. Now, from there, according to rules for exponents, this 12 and this n squared can become 12 plus x to the 12 plus n squared. Okay, and this may or may not be your preferred order. This is the way I did it when I first solved it, and I've solved it some other ways since then. Having done that, you don't need these bases. If x to the m to the 4 is equal to x to the 12 plus n squared, then you know that m to the 4 equals 12 plus n squared. Okay? Yeah? Okay. From there, I can obviously move the n to the other side by subtracting it from both sides. N squared is going to be equal to 12. Okay? Wow. That's this. That's this. Okay? So what I can do is I can factor that to become this. What I'm going to do though is I'm going to skip a step. I'm going to call this one 3. This is going to become 3. It becomes 3 times m squared minus n. Now remember, the m squared minus n is what you're solving for, so once you do this next step, you are done. Okay. 12 divided by 3 equals 4. Okay. And this was take 1 of this video, so if it was not perfectly smooth, at least I'm done with it.